Hello everyone. So welcome to this environmental studies, and we are in module number 2. And the module number 2, the name of the module is Advances in Energy Systems. And in my previous video of module 2, so I have covered what is all about renewable energy and then non-renewable energy, which is nothing but conventional, non-conventional. And in that, so I have explained about solar energy, that is flat plate collector, and then solar pond. So in this video, I'm going to cover this wind turbine and hydro power plant. Okay, so let us move on to the slide. So this is wind turbine. So when you look at this wind turbine, so first and foremost, before entering into this concept, I would like to explain so what is all about this wind turbine, how that wind is generated. Again, for this wind, generation of wind, so the main reason for this particular wind generation is sun. From the sun's radiation. So radiation comes and falls on the earth's surface first, and then from the earth's surface that is reflected back, and then the wind which is closer to the surface level of earth will be heated up. So what happens when that lower level, that wind which is heated up, slowly the density comes down. So whenever this molecules, when it is heated up, density comes down. So it becomes lighter dense air or wind. So when it is lighter in weight, slowly what happens, this tries to move up and a heavier dense wind try to come down. So there will be a circulation. Even you can see ventilators in our houses. So ventilators are kept on top because all that smoke or lighter particles will try to move up. The same way here, the wind, so lighter particles, molecules will try to go up, and heavy dense particles, molecules will come down. So there will be a circulation. So this circulation is nothing but, the cycle is nothing but wind. So this is how the wind formation takes place. And with the help of this wind formation, or the frequency of wind, so we are trying to get the energy from the wind energy. So what we are going to do in this, we are going to construct a tower. So there is a tower, and then on top of it, so generators are placed, and that is connected to blades or rotors. So it can be 2-blade rotor, or it can be 3-blade rotors. Okay, so on top of the tower, so what are the different components that we can see is low speed shaft. First there will be a shaft. The first one will get we'll see that low speed shaft, and second one is gearbox, and then third one is high speed shaft, and the next one is generator. Okay, the entire thing is called as a nacelle. So in this inside the cut portion, if you see that, so these are the things that we come across: the low speed shaft, gearbox, generator. So all these things will be there. So what happens, that is placed where the wind intensity is more. When wind intensity is more, the wind will come and hit turbine blades, and then this blades or rotor will rotate. This turbine will rotate. So what happens when it rotates, the shaft is connected to this turbine blade, so the shaft also will rotate. So when shaft rotates, that gearbox will be there, that will be used for changing the gear speeds. That gearbox will be used. So this entire shaft is connected to generator, electric generator. So in this electric generator, so there will be a magnetic material. You know how that electricity is produced from the electrical generator. Okay, electrical students will understand even better. So there will be a magnet, and then coils are wound around the generator, what you call magnetic material, and when it rotates, what happens, magnetic flux is produced. It cuts the magnetic flux, and then EMF is induced. That EMF, electromotive force, that EMF is nothing but electricity. That produced electricity is taken from through the some other channel, and that electricity will be used for some other purpose. So this is how this energy is generated, that electric energy is generated with the help of this flowing wind. Okay, so this is the working principle. And next you can see what are the advantages, disadvantages. You can see how it, where and all this can be, tower can be installed, all those things you can check. So where wind intensity is more, there you can construct this tower. And this is seasonal, and it will not be available all the time. So whenever this wind intensity is more, there where that time, particular time, we can produce this electricity. and the construction cost is more. And advantage is once it is constructed, and there is no skilled operator is required, so we can continuously produce the electricity. So these are the some of the advantages and disadvantages of this wind turbine. So explanation is given over there, so we can go through this. Next, coming to this hydro power plant. Okay, so what is this hydro? Hydro means water. With the help of this water, we get the energy out of it. So that is nothing but a hydro power plant. So this is the layout of hydroelectric power plant. So for this, we have to construct a dam, and then there is a reservoir. From the reservoir, water is collected. Water is stored in the reservoir. So what are the components are there available in this? There is first one is a dam, and there is a penstock, that is a channel, and there is a gate, and there is a surge tank, then inlet valve, and there is a turbine, and then there is electric generator, and then there is a transformer, and there is a power station, and the remaining thing, the draft tube is there, and there is a tail race. So these are the components that you come across in this hydro power plant. So first and foremost, once the dam is constructed, from through rain water, so water is collected in the reservoir. From there, water starts flowing. When you open up the valve, so water starts flowing through penstock. There is a gate valve. When you open up and fix the pressure, so with the same pressure reading, so water starts flowing through surge tank, and then there is a surge tank where water will be collected over there. Again, through penstock, water flows. There is an inlet gate valve for before the turbine. So when you open up, the water starts flowing to the turbine. So there will be turbine inside the turbine. This is a mechanical component. So there will be a rotor, and the number of blades will be there, and that is connected to a shaft. Shaft is nothing but a rotating element. The water comes and hits the turbine blades. What happens? The entire turbine will rotate. When turbine rotates, what happens? Since it is connected to shaft, shaft also will be rotated. And this particular shaft is connected to electrical generator. So there will be production of electricity. So as I have told you the previous thing, that wind turbine, the same way, so electricity is generated. That generated electricity is with the help of this transmission lines, it will go to the transformer, and then it will go to the powerhouse. And the remaining water from the turbine will be there will be a draft tube. Through the draft tube, water will be collected and will come back to the tail race. So this is the working principle of hydropower plant or hydraulic turbines, right? So this is how the electricity is generated with the help of hydropower plant. And this is the explanation of this hydropower plant. Coming to this nuclear power. So in this nuclear power, we can see one is nuclear fission and nuclear fusion. Okay, so this nuclear, you might have studied this in the earlier stage, like nuclear fission in the sense, once the nucleus atoms come and collide with each other, and they split into small particles, they divide. So that is nothing but when they divide, when the bombardment takes place, when they split, so many particles will be split, and then it emits radiation. So that is nothing but a nuclear fission. So there is a light particles, the light energy, and radiation will come out. So that is nothing but nuclear fission. So the most common nuclear fuels are uranium 235. Okay, not all nuclear fuels are used in fission chain reactions. So next one is a nuclear fusion. There is a combination of atoms. When it combine with each other, then they produce radiation or light. So that is nothing but a fusion. This nuclear fusion is a combining of two nuclei with low masses to form one nucleus of larger mass. So nuclear fusion reactions are also called thermonuclear reactions. For example, I'll take the sun's radiation. So hydrogen helium atoms come together and combine with each other, and then they produce light energy. That is called sunlight radiation. Okay, so that is example for nuclear fusion. And the uranium atoms were, after colliding with each other and split into small atoms and neutrons, and then it emits radiation. So that is nothing but nuclear fission. And next one is biofuels. So Biological material derived from living or recently living organisms, plants, derived materials. So biofuels are like solid or liquid or gaseous energy. So converted into, and biomass is a biological organic matter. So the biofuels are taken from, so it is nuclear, what you call, so natural gas, not nuclear, it is a natural gas. So it is nothing, it is taken from the fossil fuels, or it is taken from the what you call, energy which is available under the ocean. So much amount of living organisms are placed under the ocean, and from there they take out the energy from there, the living organisms. So all these things, it is in the solid state and liquid state and gaseous state. So that is nothing but biomass. So these are the some of the nuclear energies that I have covered, renewable, non-renewable, and some of the examples that we have seen. Okay. So in the next video, so we'll cover some other topics of this advance in the energy, advances of energy system. Okay. Thank you very much.